I was just saying how my camera was going to freeze right now. As we start the show, my camera freezes. My nice camera over here that I've been trying to fix for the last, gosh, I don't even know how long, 3 or 4 months now, cannot figure it out. Anyways, hello everyone, and welcome to Arm's Innovation Coffee. Of course, as I said, brought to you by Arm. My name is Robert Wolf, and I am your host today and every Thursday at 5 p.m. UTC, where innovation meets the ecosystem, meets all of the fun stuff that people are doing around the world on Arm, of course, with your nice cup of coffee or tea. Now, today we are joined by two amazing guests, of which I believe both have been on the show before. I know at least one of them has. So we're joined by Darragh Grealish, who is the CTO and co-founder of 56K Cloud. I'm sure you've heard of them. He's also an Arm innovator and an AWS community builder. We're also joined by Marc Meunier, who is the software ecosystem development manager at Arm. And today we're going to talk about, as the title of this video shows, securing AWS Greengrass with PARSEC. PARSEC stands for the Platform Abstraction for Security. And in this episode, we're going to cover it all. We're going to start from the top. We're going to talk about what is PARSEC, what is AWS Greengrass, how do these two things work together, and what has been happening in the world of PARSEC over the last year or since its inception and where it's going. So without further ado, I want to bring on our guests and remind everyone while you're watching, if you enjoy this video, don't forget to smash that like button. Don't forget to follow the Arm Software Developer YouTube channel. And if you have any questions throughout this live stream, post that over in the chat on the right-hand side, and we will get those questions to our guests as soon as possible. All right, so let's bring Marc and Darragh in. Or should I go alphabetically? Let's bring Darragh and Marc in. Hey, Darragh, Marc, welcome. Welcome to the show. Hello. Yeah, I was commenting in the green room. Darragh, I love the setup you have this time on the couch. And this is really cool. So usually the way we start these calls off, and I know, Darragh, you've for sure been on this call before, but if anyone out there is watching either now live or on demand later, we like that the guests get to know, our viewers get to know the guests. And so, Darragh, let's start with you. If you could take a minute, tell us a little bit about yourself, what you do, what's 56K Cloud, tell us about your company, and, just kind of take a couple minutes for that.
Yeah, sure. Hi, I'm Darragh. I'm been here before, but not on the sofa from the Arm Innovator podcast. Yeah, I'm from Ireland, as you can see from the flag, but married to a Swiss. That's why there's a Swiss and Irish flag together. And I'm come from Ireland. I studied embedded systems, so all the hardware and everything. Actually, I think I think one of the ARM CPUs was my first thing I programmed in college, and I then also focus on cloud and the integration between the cloud, the technology, the public cloud, down to like the devices and the software on the devices. So we're going to look at some hardware later. Excited to show you guys. And then we also, as 56K Cloud, we're also AWS partner, soon to be advanced, and our focus is like the AWS community builders project is really like showcasing the technology, the integration between the edge and IoT, and now recently with 5G and how 5G is exposing the technology of the network to developers, and like the cloud has done. And this is why we still have an office, because we have too much hardware. Okay.
That's awesome. Yeah, cool. So you got everything behind you showcasing. So if anyone forgot or forgets what Darragh said right now, just remember he's got the flag behind him. He's got the AWS community builders hat. He's got it all. Cool. Did you want to show something there? Sorry, Darragh.
Well, oh no, that's just the AWS partner flag.
Oh, nice. All right, cool. And he's an AWS partner. Official. There you go.
We need an ARM one. Where's the ARM one?
Yeah, exactly. Well, maybe during the Innovator Summit this year, if we can get one going.
Yeah.
So, Marc, your turn. You're up. Who are you? Good. What do you do?
Thanks, Robert. Well, I get the privilege of working with companies like 56K Cloud in advancing technology, focused on software, mainly in open source, looking for ways to help the ecosystem grow. And yeah, so I spend all my time working with partners in this space. And I'm actually based up in Canada. I'm in Waterloo, Canada. I'm one of the only Arm employees up here. It's too cold up here for the rest of them, so we'll hold the fort.
Isn't there a song or a band called Waterloo? I feel like there's a song about Waterloo. But yeah.
Probably a different Waterloo, but yes.
All right, cool. So we've already gone through the introductions, and now let's go through a little bit of an icebreaker round, because I know each of you brought some really cool hardware to show us. So let's queue up Innovation Coffee Cribs. Innovation Coffee Cribs. This is where our guests get to show us some of the cool stuff they're working on, or some of the cool stuff they just kind of have around their desk or in their office. So let's start with you, Mark. I know you have some. You were saying you had some cool stuff, some vintage things, and some cool stuff sitting around your area there that you could share.
Yeah, so I'm an engineer at heart, so I'm always tinkering around with things. I worked for BlackBerry for a number of years, so I've got a number of devices here. One is a BlackBerry Z10 and an old BlackBerry Q10. And then I have the heart of a jukebox here. It plays 45s. It doesn't play them very well. There's something broken in it, and it's made in Germany. So I got to read German manuals to figure out how it works and figure out how I'm going to fix that. I've got a book here on trust. This was written by Mike Bursell. He's a partner of ours in the Confidential Compute Consortium. So great book I need to finish reading. I think that's it. Those were the exciting things on my desk.
I remember in the BlackBerry days, I had a BlackBerry. Like as phones evolved, right? You had the flip phones, the StarTACs. Of course, I had one of those. But when I got my BlackBerry, it was one of the phones I think I held on to the longest. And then the iPhone came out while I had the BlackBerry. And I was so resistant to switching to an iPhone. I wanted the buttons. I was like, no, why the heck would I not want buttons? Like I can type without looking because I can feel the buttons. And then one day I left my BlackBerry on the counter checking out at a grocery store. And I was so sad. I lost my BlackBerry. I was like, oh no, okay, well, maybe this is just a sign I got to switch now. And so then I switched. And by then I think they were on like iPhone 3 or iPhone 4. So I held out for like 3 iterations of iPhones, battling iPhoners as to why BlackBerry was better for a minute. And then I made the switch and I've been with iPhone ever since. Yeah. But yeah, BlackBerries were rad back in the day. Darragh, you're up. Sorry, I kind of tangented off there, but BlackBerries,
Yeah. Maybe I should give some hardware I have on the desk here, table here, actually give some of the background story with Mark and I. So let me see if I can zoom in here, Mark. You remember this, Mark? How we met?
Oh yeah, that looks familiar.
Let me see, let it get focused. The lights killing. Yeah, that's a Siemens Smart Gateway. It's one of these with PLC. And way back in the Docker days, we were working with. I met Mark when he was at Docker, and these guys I still have here because they're running. I think the ARM, an ARM 32-bit. I think the Cortex A53 or something. And these are DIN rail mountable home automation or room automation devices, so they connect into the legacy room automation. So I have this in the desk, and Mark remembers these projects.
I thought you were supposed to return those.
No, it's got the logos. No. And then,
that's his flag. He claimed them. They're his now.
The other one. So this is a book I got about 5G because it's a new thing. We've been getting into the last year. And the interesting thing about this one is, if the thing would focus, it's called The Dark Side of 5G. And I actually sent it to my home address, and my mother ended up reading it because she was like, I want to know about this 5G stuff. It says dark side on it. So it was interesting for someone to really write a book and actually write that there. The other hardware I'll show you later. We'll leave the matchup in later, but that's the Cube RB5. That's you remember this, Mark? This is a Qualcomm's.
That's a Qualcomm, yeah.
Yeah. So if you look at the Galaxy S22 or S21, same CPU. Basically you can buy it as a development platform. this thing is pretty beefy. It's got up to 8 cores. We have a TPM added here for the PARSEC work, and it also, this one is particularly exposed, or it's got a focus on automotive, because it has a vision board here on the top, and these are automotive, vision interfaces for cameras that would be there. So that's pretty cool. It's 96 boards compatible, so we're running a secure 96 TPM there with an Infron on it. And I have a 5G variant as well, but you'd have to use the other camera. It's actually running, the device one. But anyways, we could go on forever.
Oh, guys and their toys, right? That's what happens.
Yes, there's a robot over there. Okay. Oh, Mark,
His lips are moving, but we can't hear him.
Yeah. Well, anyways, while he gets that set up, I can show you around the room here. We have Vegas lights, and then, oh, that's the wrong way. That's the door. Until
You in your office, Darragh? Is this your office?
Yeah, I think I call it more of a lab now, but we've got a robot here as well. That's as old as I am. That robot. That says Stabile. So you remember the Puma? This is from Unimation, a US company. So I still have to get this little guy running. I think he's in the 1980s. This little robot.
Yeah, you have I see is a TX2. I thought that looks like the Xavier board box.
Yeah,
there you got your Xavier right there.
Yeah.
Oh, and you have the RB5 kit right there too.
Yes. Yeah.
The RB, nice. All right, cool. Sorry, I'm back. I dropped off there for a second, and then I had to move. I was mentioning this to you guys, in the green room, but it's working with these USB hubs, all the bandwidth, it's messing my stuff up. Hybrid Robotics, Hibonics says he has a robot right here too. I'm wondering what it is. I just found out that Hybrid Robotics is from my area, and so I might be able to meet up with him one day. It'd be cool. Maybe you could come over here, Hibonics, and you could come to my garage, and we could do a stream from here together with all your robots. That might be fun. Okay, cool. So we did the icebreakers. We got to meet you all. Let's now dive into the heart of this subject, which is PARSEC and AWS Greengrass. So I think, Mark, we're going to start with you. All right, let's talk about PARSEC, high level. What is it? It still stands for the Platform Abstraction for Security, right?
It does.
Okay, because sometimes these acronyms change over time.
I know.
But that's good. All right, so we're on track there. I'll hand it over to you. You said you might have some slides.
I do have some slides. I'm going to try to share that in just a second here. Hopefully they pop up. And really, this is just kind of keep us on track, right? We don't want to deviate too much from our topic here. You've heard Darragh talk about our engagement back in the days when I was at Docker. We were leading programs, bringing technology to Siemens at the time. And, when we think about what's happening with computation at the edge and this movement of cloud native development in the cloud, there's really this big intersection that's happening where the cloud developers and their tools that they use to develop code is now being leveraged to develop applications that are deployed at the edge. The challenge, though, is at the edge, you've got a higher level of surface attack, right? There's a need for a higher degree of security when you're deploying your applications to the edge. And one of the tools that is really helping to protect your devices is the ability to leverage a hardware root of trust to anchor your security when you're securing your edge devices.
Mark?
Yes.
Real quick, when you say like a greater attack surface or more area of attack, is this meaning there are a greater diversity of devices out there, or is it meaning that the devices are closer to a human interface that could possibly tamper with the device physically?
Well, you bring up a good point, Robert. So I guess if you take a step back from just the surface of attack, which is the exposure of the device at the edge, there's also the fact that there's a diversity of devices out there that also plays into the challenges of securing your edge devices. An example of that is developing an application for a specific piece of hardware. And as you know, with supply chain these days, you might not be able to get the chips that you had originally designed. And if you switch that and you need to design for a different, security interface, then you've got to restart. And this is where Parsec comes in. This is where we try to, alleviate that direct tie to the hardware that you're using.
That answered my question. Thank you.
Darragh, did you have anything to add here on the Parsec? Why do you think Parsec is important for edge and for IoT developments?
I can't hear Darragh. Can you?
Sorry. The speed of I muted a little bit. The speed of development, like right now, you see how quick to develop in the cloud. You basically just take a credit card, a laptop, internet, and then you can start to build apps, to build a lot of stuff. That kind of developer workflow and that, like you said, the cloud native experience, that hasn't translated so well into the embedded world or these on these edge devices that that could benefit from it. So Parsec is just one of those ways to encapsulize and, let's say, modernize the approach by using those tools and libraries that Parsec is building to enable all the vendors to work like. So I mentioned here, I have like maybe 3 types of devices on the here being used, and I might be quickly evaluating which one am I going to build a washing machine with or the robot controller or a firewall. I need to be able to, of course, address the security requirement very, very quickly. And at the same time, any of those ODMs, they're going to be building towards support on Parsec. And then the developers who are consuming that, who want to build those end devices, they're also, if you're making it more accessible, you're going to make your platform, your offering more accessible to a greater range of developers. They don't need to get deep into the embedded C or even hit assembly, let's say, for debugging stuff. It's just out of the box. They can start, and then they can enter that let's say embedded systems world or edge device world that which is originally kind of like just limited to those C programmers, guys. I mean, we saw the books here, so I had to read all of those to do assembly.
Yeah, it's quite challenging when you consider the interfaces to the hardware. If you can abstract that, that'd be ideal. And this is where Parsec comes in. So when you consider your interface to security, Parsec sits just above your OS. It sits in the user space, but it connects on the back end to the hardware root of trust in your system. So here we have a diagram showing all the various hardware root of trust that you may encounter at the edge. You have Parsec sitting in the middle, and then above that, the applications that are running and that would demand these security functions, they make their calls into Parsec. That doesn't change. So that interface is fixed with Parsec, and then the back end is handled by the service that's running in this project.
Yeah, maybe we want to make it full screen, the presentation. You can see the drawing better.
Yeah, that's a good idea. I can do that. Let's see.
Presentation mode. Are there any? Let's see if there's any nice transitions that you put in there. Oh,
I did. No, I have some transitions. I'll get to those soon.
Okay.
So we talked a little bit about the advantages of Parsec, right? So simplifying security is a big one, right? So this idea of being able to abstract the hardware root of trust, develop your applications with one API, and not having to worry if you have to move from one device to another. And of course, that enables portability. It enables portability in 2 ways. One, like I described, various devices at the edge. It also, and this goes down to the accelerates development point here, it allows you to develop your application in the cloud using Parsec and then a software model for a security root of trust. And then you can develop your application, debug it, and when you move it to your end device, you're just switching out the back-end provider in Parsec for the specific root of trust in your device. And your application code is already debugged and everything will work just the same in the end device. So that's pretty powerful. And I think that's where one of the biggest advantages of using that abstraction layer for development.
This is really nice point, actually, you know, because sometimes when you start developing, you don't realize, let's say, how much power you needed or how much you didn't need and how many devices you might end up deploying. And so, you know, as you start scaling something out and building out your product or whatever you're building, if you need to transition to another device, knowing that all of the components of your software stack are available and easy to use across multiple devices makes it a lot easier, right? Your engineering time is reduced. It's nice.
And now, like, because Parsec is a modern application, it enables functionality that is not available with today's hardware root of trust. So this whole idea of isolated applications is the ability of Parsec to broker your access to the hardware root of trust, which is really designed for a single access point. If you have multi-tenancy needs in your device, you can use Parsec to isolate these various calls into the root of trust, which is another very powerful feature of Parsec.
And you were saying, I think you already mentioned this, but like you were saying, this is already in OpenSUSE and Fedora. So it's already functioning. So basically any device that runs Fedora or OpenSUSE, you should also be able to run Parsec on?
Yeah, and that's the vision, right? When you think about what we're doing with Parsec, our vision is for Parsec to come integrated into the OS that you use so that you have access to this interface from day one. And we've done that integration with OpenSUSE, with Fedora, and we have recipes for Yocto. Out of the box, you can be up and running. And for Linux distros that don't have Parsec pre-integrated, it's a simple, you know, set of commands to pull it down and have it up and running.
Are you working with Ubuntu at all? Is this something that might happen with Ubuntu or not yet?
We definitely have aspirations to have this in Ubuntu as well. Absolutely.
Nice. Very cool.
Yeah. So we're intersecting the distros, we're
You just said.
intersecting the OEMs and the SIPs, you know, the development kits. We're hoping that Parsec will become, you know, the de facto standard for accessing your root of trust in all these devices, all these environments.
Yeah, Hibonics actually comments here. He says there's always been a problem getting to and building the security features into a project. So maybe this is your solution here, Hibonics. And yeah, he commented literally as I was talking about Ubuntu. He's like, we need it in Ubuntu also.
Yeah. So there are partners that have developed and are using Parsec with Ubuntu. So that will all work. It just doesn't come preloaded, right?
Yeah.
That takes a little bit more work, as you can imagine. One of the questions I get often is, what's the difference between Parsec and PKCS11 interface, which is, you know, commonly used in the world today? And I would say the big difference is that while PKCS11 is an old standard, it's been modified, right? If you're going to use a device that claims to be supporting PKCS11, you're likely to find out that there are all kinds of nuances that make it slightly different. And you're going to have to test your software against all those different variants. When you look at Parsec on the other side, that nuance is handled by Parsec. In fact, Parsec connects to all these various PKCS11 variants and can abstract them. So you really do have a standard interface regardless of what you're connecting to. Yeah, this is just a quick slide to explain how it works, but I think by now you've got a pretty good idea. We've got this client interface, which exposes the APIs to the applications. You pick the one that matches your programming language. So these come in a variety of languages, and I'll get into that list shortly later. Here you got the Parsec service, right? So that's doing the computations and, you know, providing the access to the backend provider, which is connecting to your root of trust. So this is where the magic takes place. This is where all the intricacies of the root of trust are handled. So there's a number of backends, of course. You just pick the one that matches your device. And then, you know, you could have an environment that matches your development stream with a software root of trust. And then you can have one that matches your end device where you just swap out the backend provider. Everything else looks the same. A lot of companies involved in this project. You know, we've been working with a number of partners. They've been integrating Parsec. They've been adding code to Parsec. We've done joint presentations with Spiffy. There's a lot of activity, and a lot of this is happening, it's ramping up. So this is all very much exploding in the last 6 months.
The more the merrier.
Absolutely. Yeah. In order for this to really, be sustainable, it has to have a community of supporters. And of course, the project is in the CNCF. So it's a sandbox project as of about a year and a half ago. And we're now looking at taking the steps to bring this to incubation. So we're already looking at maturing this to the next level in the sandbox.
Nice.
Just a quick slide here to show that ARM has a project called Cassini, and we're leveraging Parsec as part of that umbrella project. And we're bringing this to the ecosystem along with SystemReady, along with PSA. And we're going to make Parsec the de facto standard for security in all of ARM's devices at the edge. So it's part of a larger campaign. It's not going away. So I mentioned this earlier, these different building blocks. Here's kind of the map of what's been developed. This is a very high level map. There's a more detailed map in our book that sits in GitHub, where the engineering team keeps a really strict tally of all the different development that's taking place. There's the link popping up. But in a nutshell, you've got these client interfaces in Rust, C, Go language. We'll talk a lot more about the Java interface. There's a CLI tool to help you debug. We've done identification with Spiffy. We can use peer credentials as well to help you isolate your access to the root of trust. A number of APIs here. The yellow ones are maybe not coming soon, maybe more, half implemented. Few elements of it are there, and we're continuing to build this out. And then on the back end, while this list is growing, all the time, NETPM 2.0, PKCS 11 is supported, and a few other unique ones have been added on. This is where I had a animation in my slide, which didn't work. So I'll just talk through this very quickly. And this is going to be the topic of discussion that Darragh is going to walk us through as well. We did a lot of work just before the holidays with 56K Cloud to bring Parsec to the Greengrass ecosystem. What does that mean in a nutshell at a very high level? If you have a device that you want to connect into Greengrass, you install Parsec and you provision your keys directly in your root of trust in your device. So that never leaves the root of trust. You then install your Greengrass core, you get that up and running, and you exchange a certificate with the cloud service to make that link secure. Again, your keys are never leaving your device. So you're really leveraging the highest level of security that you can. And then once you do that, then your security connections are locked, your identity of your device is secure, and you're up and running, and you've really created a firewall around your device. And that's the vision here, the idea of having Greengrass support the Parsec interface and allowing for all these devices with various root of trust to connect into this ecosystem so that you're not left with leaving your keys in plain text. You're not transferring your keys across the network. So it's a very, very powerful message here.
So we got a question that popped up here in the chat. Is that okay if we take it real quick?
Absolutely.
So the question is from Hibonics. I'm going to move Darragh down here for a second. Would it be possible to integrate a Docker image into an existing project? I can run Docker images on Ubuntu. And I believe a Docker image with Parsec.
So Parsec is exposed to at the OS level. There's a way to connect that into your applications that are running in a container. When you're saying Docker image, though, my memory of Docker and the way that your containers are built, you're pulling images from various sources and you're creating your container kind of on the fly, or you can develop that way. So I'm not exactly sure what is meant by Docker image here.
We'll let him clarify. We'll let him clarify. So maybe
Okay.
he'll clarify right now. We can get that.
I mean, you can certainly run Parsec in a container. That's how we do it, and we'll show you later in the demo. And you can consume Parsec from another container. So we'll be happy to demonstrate that. And focus is Parsec to be multi-tenant. you know. So the idea is if you had a single root of trust on the physical hardware, and you want, you know, to have multiple applications accessing that single root of trust, then Parsec can facilitate that multi-tenant access as well.
Yeah, so I think that answered his question there. He's like, yes. So I believe it's about, you know, having Parsec in an image, number one, and being able to access Parsec from an image, number two. So I believe that was pretty much the cool. All right, got that. All right.
Perfect.
Ooh, wrong one.
Yeah.
And I think at this point, we're ready to jump into the specifics around the Greengrass integration. So Darragh, your turn.
Hey.
You're up.
All right.
Demo time.
Cool. Okay, then it's changing to Parsec, so I just go like this.
so real quick, Darragh, if we can, for this demo, I'd like to kind of take it from the base up, right? So like, what hardware are you using? What's your software stack? And then let's cover the demo.
Yeah.
But first, let's go through the explanation.
Can you turn on the other camera? Yeah.
Boom. All right. Hardware. Look at that.
Here we go. Yeah, great. Make yourself full screen. So this is the Macchiato bin, the device. So basically, the demo is actually running on multiple devices. So as you've seen, it's also running on an RB5. So that guy, this one, and we have two of them here. So the first one I'll show you. This is an RB5. This is a Qualcomm device. This is actually one with a 5G modem on it, but it's actually stacked. So you can see it's got multiple stacks. So
and that's from the 96 boards form factor. So that's the 96 boards consumer edition form factor. You can go read more about it at 96boards.org.
Yes. So here you got the 96 boards interface and everything, and this one's coming from Thundercom. So there's two variants of it, just to show you. So there's the vision sensor variant. So that's one where basically it's the same Qualcomm RB5 platform underneath. So in this CPU in the stack of cards, and then this one's got like the vision board, as I mentioned, with the TPM in it. And then this one is with the 5G connectivity card, so that you can use it as 5G, because it's actually the main objective of this is to be able to build those mobility or automotive or like autonomous robot kind of use cases with vision and everything computed all in one platform, so you don't have to have a separate system for connectivity, a separate system for security system. So this was the hardware we used, in the beginning, and then this is the main demo hardware. So this is a Macchiato bin, Armada 8040 board. It is this. If you saw earlier in Marc's presentation, we mentioned the SystemReady program, and this is an ES SystemReady device. So that means that it comes with the firmware, the open firmware, the EDK2 working out of the box. It means these interfaces, the MAC addresses, you see those interfaces. So this board is like particularly focused at CPEs, like those modems that you see that you get from your operator, more the professional ones where you might have. This has two 10 gig SFP plus ports with an Ethernet, so 10 gig Ethernet port as well. And then it's got a third one, which is for what's called XGPON, so 10 gigabit internet connection. So it might be focused on like a firewall appliance or a pretty beefy maybe NAS. Actually, you do see that in NAS in this, not Synology, the QNAP NASs use this 8040 Armada processor, and then it's got some RAM here as well. So this guy is rigged up with 4 gigs. It's running Fedora. So as Marc said, it comes out of the box with Parsec running on it. This guy's running Docker containers, and it's I think it's 2 times or 4 times 1.2 gigabits. So this one's built on either the Cortex A72 or A53. And,
A53, pretty sure.
Yeah, A53. So and for like $300-400, it's a pretty beefy platform. So what I actually have plugged in here is I have my operating system running on the SD card, micro SD card, and then I just have a boot. I flashed it with the USB device.
Is there any onboard storage?
In this one, there is, I think, about 2 gigs or 4 gigs. So you can boot from 3 different platforms. So you can configure the firmware to boot from the EMMC, and also the SD card and the USB. And
so you're choosing to boot from the SD card.
Because I need a bigger partition for the operating system, but the firmware is flashed on it, and then gives you the boot And you got a PCI Express. So you could actually put a graphics card in it and use it as a kind of Raspberry Pi clone, you know. But when you see the big ATA connector with SATA, you know this is like designed as a two-bay NAS kind of example with a bunch of Ethernet. So I'm sure that like the likes of QNAP or someone probably have, you know, external eSATA interface, then your 2 hard drives, then maybe LACP on 2 10 gig interfaces, and then, you know, another LAN port there. So various different use cases, but that's from Solid Run, the Macchiato bin that you know, this is an off-the-shelf thing you can get running. Okay, so that's like the hardware going all the way down. So what I'll do is go and share my screen now. Oh.
Now code, hardware then code.
Yeah. So do I finish with a diagram?
Can we bring you over here so we can see you?
Yeah.
That's so cool. You have this like remote control camera. I feel like I need to get one of those now.
Yeah, it's actually one of the first things we bought for the office, and now we make proper use of it.
For some reason, when I see you in your outfit, it looks like you're about to go out and catch some Pokemon.
Pokemon. It should be skiing with this thing, you know. It's just a big cold. But let me now breathe. There was no questions on the hardware, no. So
no, but Hibonics did say that now you're speaking his language.
Cool stuff. So, are you able to add the screen? Yeah. Oh yeah. Good. Yeah. So
right.
So we saw the hardware there. We learned about the hardware. We learned about Marc speaking about the overview of Parsec and the objective of it. So basically, you know, what we've been doing together is the last few months we've been actually taking that and implementing that. And we started with this use case with, you know, let's get Parsec to use Greengrass on a device. So, and look at the entire spectrum of what's required. So from the hardware root of trust all the way to an actual application use case running on it. So that meant that, you know, there was a bit of community work to do for Parsec. And what we had done a bit extra for Parsec is we built a Java library. So Parsec, you know, has a bunch of libraries that you can use to consume it. These client libraries, as Marc mentioned. And what we had to do is implement a Java client. And inside that Java client, it's not just a basic Java client. It's also in Java, you have what's called JCA, so the actual Java cryptography architecture. So even in the Java ecosystem, we're using Parsec in connecting Parsec in a native way in Java. And so that means that anyone using this Java client library who already are using JCA can essentially swap in from a different like PKS11 client library into the Parsec one. So the accessibility is and the kind of, let's say technical onboarding or drain is quick. You know, you can reach a quick win. And so this you can find on the Parsec website as a Parsec client Java library. It's a Maven build. It's currently we're working with it to finish up a few patches on it. But right now it's we have this working together with the functions. So the kind of simple things like in this demo, what you're going to see is we're going to access the keys, create a key. We're going to assign that keys, and then we're going to verify the keys. So there's a few core functions here that we're exposing into the JCA. So here's a list of the JCA examples. So this is deep cryptography stuff. But basically, what you need to be able to do is that if you have a device that gets manufactured, like a TV set-top box, for example, which has maybe some localized keys that are burned into it at a manufacturing point to decode those satellite signals or TV streams, then you need to consume that private keys in your application somehow. And what you're usually doing there is you're using, signing the keys, you're creating a signing request, then you're sending data, you're going to get to encrypt it, and then once you've encrypted and signed it, then you want to use that in your application. So that's why the core functionality of the JCA is quite tight, But let's get to the use case, because then when you see the use case running, it's easier to understand Java library. And
real quick, Darragh, we did get a question from Hibonics here. He's asking, is there now or will there be a Python interface to Parsec?
Ooh. I think
You're
there
muted,
should.
Mark. You're
But
muted, Mark.
it's close to the.
I'm not allowed to say.
Uh,
Just kidding, just kidding. No, I think that would be really cool. Absolutely. You know, the more client interfaces that we can develop, the better. But you know what? To be honest, it hasn't come up yet in a application, in a use case. So if it comes up, yeah, let's do it. Let's get that Python interface coded up for Parsec.
I mean, when you were talking to me about this yesterday, Darragh, when you were talking about this new Java interface, like there was a particular individual I think that had to put a lot of time into getting that built, right? Like, I mean, someone was contributing pretty heavily to this.
Yeah. So I was hoping that we could get him on the call, but we'll have to do a deep dive session at some point. And so the two people who were behind this project, from a major perspective, is Sam Spiker and Urs Keller, and they were working. They work with us on their various different kind of freelance projects because they're like deep in that Java ecosystem. You know, they stain. And one of the important also kind of reasons to get people involved that are deep in the Java ecosystem and come with that decades of experiences, you want this designed well. You want this to resonate within the Java community. You want this to, meet with the Java rules, because Java is one of those. I mean, an easy comparison is, let's take a book. This is only one volume of learning Java. And so it's a massive how do you say, platform, and when you look at other modern languages like Rust and Golang and everything, I mean they're lower level, so they don't have as many not such a broad ecosystem as Java is, and also it's like I think the first or the second most popular programming language there. It's like Python is next. I think they're up there with them. They're big ecosystems.
Yeah. So that's awesome. And sorry, pulling it back to the Python question here. Hibonics brings up a good point. Python's very heavily used in robotics, right? So robotics. If you're talking about devices at the edge, I mean, robots are getting closer and closer to human interaction, right? Like, I have robots in my house, quote unquote, per se, right? And so, as we start getting more and more robots in our house, robot delivery services and things like this, like, I can't see why Parsec or some form of security like this would not be necessary, right? Like, so that's pretty good. And then he just brings up a point. ROS, robot operating system, is also major platform.
Yeah, I mean, that's certainly something that Robert Ross runs on a lot of things, and one use case, another use case for Parsec is to build it. But I mean, if you go back, Parsec is relatively a new open source project in the CNCF and the ecosystem. I think it's also, correct me if I'm wrong, Mark, I think now it's matured to above Sandbox.
Well, we're going to work to get it to incubation, hopefully by the summer. That's our goal. So that'll be the level, one level up. Sandbox is your openator project. It's your experimental project. And then incubation means they're adopted and they're in production. And we're ready for that next stage.
Yeah. Nice.
So please, if you want to, you can take the Java library and the Golang library and the Rust library as an example of what a Parsec library should look like, and love to see Python. Yeah.
There you go. There you go. Hibonics, a summer project.
Cool. Great. So I went over the hardware, as you saw. As I mentioned, it's SystemReady ES certified just recently in July. So ES is embedded server, like I mentioned. A NAS and an pretty advanced firewall or whatever appliance would fit that kind of embedded server market. It also scales up to bigger stuff. And I mentioned it's at A72. It's 16 gigs RAM. So this one came with 4 gigs. So I wanted to keep it quite small. There's other ones. And just to correct my point on the WAN interface, it's 2.5 gigabits SPF plus. Sorry about that. That's how big it is. And it has local storage. Yeah. And this one, because it's system ready, then it comes with 3 operating systems that should run pretty much out of the box. So Ubuntu, Fedora 35. We'll see Fedora in this example in a minute.
I think that's supposed to say EMMC, right? Not EMCC.
Yes.
All right.
Okay, but let's get to the demo. So what the setup looks like, and this is kind of our reference deployment in the context of AWS and Greengrass. So what we did is we worked with, like Mark said, with AWS to build in the ability for Greengrass to include third-party plugins, for different services. So Greengrass is this device management. It starts simply as a device management service. Like there's multiple features under Greengrass. So it's like under the IoT kind of offering in AWS, and you'll see in the AWS console when I show you later. But we were focusing on Greengrass V2, so it's Nucleus. That's the second version of the implementation, and it's a complete rewrite of AWS Greengrass. It's actually open source as well, and that made it very accessible for us to extend and develop this PARSEC plugin into the Greengrass ecosystem. But it also allows customers who are using Greengrass on these devices to also extend their application and manage their application deployments and deployments there. And it does a lot of the heavy lifting in terms of communication, managing the device, getting data to the device securely back and forth. And on that connectivity part and the management of the device, PARSEC encrypts or facilitates the encryption of the HTTP client here you see in the middle and the MQTT bus. So over on the right is the AWS Cloud, where we're using the AWS Certificate Manager, where we're signing certificates with them. So identifying this as a client certificate generated that identifies that thing. So this thing is in the context of AWS, it's called a thing, and then it connects to AWS IoT core service, and that's basically MQTT broker. And then in the AWS Greengrass cloud service, this is used for bootstrapping, for downloading packages, for the initial provisioning process. This is this global service where you have the single endpoint that these devices can connect into. And then on the left side here, I have basically the device. So what's running on the Macchiato bin. And if you mentioned this containers, so actually this dotted box here is one container. And then on the left side, the PARSEC is the other container. Now, we don't have to use containers. We used it from a rapid development perspective, and that we wanted to be able to reproduce the demo on various different devices to demonstrate that abstraction use case of PARSEC. So it actually runs on these RB5s. It runs on my laptop. It runs on the Macchiato bin. So we've tried it on around 4 or 5 different platforms. And then what I'm going to go now into the demo is basically what I'll show you is we will first build the project. So we'll build up the PARSEC Docker container. We're using the local cryptography embed cryptography software one because the Macchiato bin does support firmware level root of trust, and that can be built into the it's called OPTEE. But in this case, we just have a quick reproducible demo where it's running the encrypt. The backend, the provider for PARSEC is encrypted. Then what it'll do is PARSEC will come up as a service. It'll generate a key, a private key, and then the PARSEC plugin then is provisioned then into the AWS Greengrass. So this component here on the left. And then when there's 2 ways Greengrass boots up. So it boots up in this provisioning way, and then it boots up when it's provisioned and it's got the certificates, it's generated a client key. Now it doesn't need those AWS credentials anymore, for example. It's already come up on the network. What it does is it restarts and then runs in an operational mode where then it can subscribe to the MQTT bus. It can make itself available on the AWS console. And then what we'll do is then do a deployment. And in that deployment, you'll see then when the HTTP and MQTT, there's an MQTT activity, you'll actually see the service called back to PARSEC to encrypt those transactions. So you'll see that. So what I'll do is I'll move over to the demo. So
and Darragh, everything that you're showing here, you've got this code available in GitHub somewhere, right?
Oh yeah. So basically, out of this, we ended up building like kind of 3 repositories. So what you can do is if you go into the GitHub, so we'll share the links, of course, in the chat. We have the main PARSEC project. This is this one. You get it bigger. And in that project, if you go into the organization, you have the various tools. So if I type client here, so the client Rust client, the Java client, and the Golang client, and then there's a mock client testing library. So here's the client Java library. that that's now open source and built. There is then also what consumes this is then the PARSEC AWS Greengrass provider. So this is the moment is in our repository. So let me get it. So if you go to over to 56K Cloud, you will see the AWS Greengrass PARSEC provider, and this is implementing this crypto SPI interface for the JCA ecosystem, so that the PARSEC client library can consume it. So in there, this is the main repository. It has the test. It has an example with running a container. You can run the configuration configure, and then the actual plugin code itself. So this is the implementation. And what that does is it consumes the PARSEC Java client library here.
So I'm seeing a lot of repos. Can you scroll down on that one? Let me see real quick. PARSEC, scroll down there. More.
Oh, here.
Okay, good. So there's documentation to accompany these.
Of course.
I just wanted to make sure because without that little README, we're just showing a bunch of files without much instructions.
Yeah.
That's
and so here you can see Sam, one of the main guys behind it, and then this is Urs Keller as well. Both in Switzerland, and he's from what's this company called? Revolut, and there's me, and so those the main guys behind it. We're also on the PARSEC community channel, so I think it's good you should join the CNCF Slack chat, and there's a channel called PARSEC, and that's where the community hangs out. And also every Tuesday, every Tuesday or every second Tuesday, there's also the community call, which you can see over there. But the three main repositories, the third one is the workshop that brings it all together. So there's a PARSEC Greengrass workshop, and that's exactly what I'm going to do right now. I have a build script that builds up the Docker implementation. So what you have is some Docker test containers. You have the Greengrass demo. You have the Greengrass client library, which we take. You have the Greengrass PARSEC provider, which wraps that Greengrass that client library. Remember, it's Java. It can't be easy. And then we have some documentation. And then in the test containers, that's where you got the Greengrass in a container, the PARSEC in a container, and then we bake that all in and build it in. So, shall we look at some?
Let's do it. Yeah. So I want to be conscious of everyone's time here. If we're able to close this out in the next 6 minutes or 5 minutes, that'd be great. Otherwise, of course, we can stay longer if we need to. But
so let's show what's running. Let's start the demo. So basically, what we do is we have what I'm going to show you is we're going to quickly start the console. We're going to get it up and going, and then what I'm going to show you is we're going to run the AWS Greengrass local console, so we can actually see the PARSEC provider in there. So I just killed the demo, so this is broken. It probably won't work. But now I'm going to do is going to start it again. So we have that build script. I'm basically going to walk you through the console. So what we're doing now is we're going to provision the PARSEC. So with the Greengrass, so it's provisioning Greengrass. There's the Macchiato bin, so the thing ID. And then what happens is it loads up the Greengrass ecosystem nucleus, and then adds in the provider. That's a PARSEC provider, the actual jar with the Java client library in there, the Java, the plugin, the JCA plugin for the Greengrass library, and then what we do is we bring it up and we provision the device. Once the device is provisioned, then you'll start to see this PARSEC crypto key SPI. And if I look at the logs so if I look at Docker PS, I have 2 containers running. If I look at the logs now, I will see transactions happening between the PARSEC service and then the log output of the Greengrass service. So now that's up, it's connected to Greengrass IoT. What we want to do now is actually see if we have something deployed. Yeah, so what I want to do is I want to deploy the debug console. So that's basically what you see here. So nothing's running at the moment. So what I'm going to do is go back to AWS. In AWS, then here I have my deployment. So AWS has this concept where you describe what applications you want on the edge. So how this works is you go in here, let's go, V3 of the demo. And when we deploy, there's a local debug console and the CLI. We already have AWS Nucleus there, but that we want to have the local debug console and the CLI, and that's going to allow us to access a local web server on the device. So let me just step through here all the defaults, default, and now I'll go deploy, and hope I didn't miss it, but job added to queue. That was really quick. What's happening here now is it got a deployment to MQTT, triggered it, and now it's downloading the packages and deploying the CLI, and you see Parsec there continuously, and then you see the Parsec signing signature calling JCA provider Parsec signature sign. So now while that's deploying, it should be up now. So all the keys have been revoked. Okay, server set. Yeah, it's I think now rebooting up again. So let's go back and get debug. So now what I'm going to do is just generate a password to access the local web server, and that certificate, that's the TLS certificate, that's coming from the Parsec service. So let's refresh here. Let's go advanced, open, debug, and now we will see local debug console. We see the normal services. So I deployed the CLI and the debug console, if you remember. Now they're running. But I can also look at internal components that we loaded. And if you remember, we had that provider.jar. That provider.jar, that's the cryptography interface, and then exposing as a Parsec provider. So that proves that
Perfect.
Greengrass is using Parsec, and we're also using Arm. So here we go.
Perfect.
Hey, Darragh, where's your live studio audience? I thought you had a live studio audience over there.
He left for a drink already.
He's gone for a drink.
He was too techy, but yeah, there we go. That's the service. So as I mentioned, the things that are happening here are, we created a deployment here over on the right. We that triggered in the MQTT bus a task to deploy it, and then it started to deploy these components here to just manage the Greengrass deployment in the CLI, and then it fetched the packages over HTTP. And the multiple calls you saw that Parsec was getting very busy was that every time it had to open up a HTTP connection or consume an MQTT message, it was going back, signing the certificates, getting the authenticating with the service with the client certificate and everything. Yeah.
Nice.
So that's next step. Next step is using the TPM properly.
Very nice. So, but we won't be able to cover that, unfortunately, today, using the TPM properly.
Yeah, it's coming. Next one.
Yes, next one. All right. Did you have another demo right now?
Well, no. I wanted to say next steps is that.
Next steps. You'll be working on that. You'll be working on that.
We have a broken demo of the TPM.
Okay. Yeah, we'll get that. We'll do that. We'll bring you on next time for the next Parsec update, maybe in a couple months.
Yeah. Okay. Any questions? Last minute questions or?
I don't think any questions have come in. There's Charlie's giving you guys a live studio audience clap right there. We did get a request for Parsec channel in our Discord server. So, Darragh, you're in the Arm software dev server. I think Mark, you're in there as well.
I am.
So I think what I'll do is I'll add a security channel. It doesn't need to be necessarily specific to Parsec, but under the based on category in Discord, I'll add a security channel there. And then, if stuff comes up, I can let you all know, and you can chime in when something happens in there.
I love the cat.
Yeah, he's the live studio audience. There you go.
Time for lunch.
Yeah, time for lunch. Yes. All right. So let's close this out. Any last words from either of you? Shameless plug, whatever you'd like to throw in there before I close out the episode.
I'm going to Barcelona next week. So if anyone's at MWC, Mobile World Congress, which is less of a techie thing, but yeah, you can come to the Arm booth. I'll be there. The guys.
We'll be together at Innovator World as well, right, in June.
Yes.
Hopefully, Darragh and I will be there, so that'll be an exciting place to meet up if you're around.
I'll even throw it out there. If anyone is at MWC and can score a picture with Darragh, I will give you a $50 Amazon gift card.
Nice.
You gotta be some rando though. Darragh can't know you. You have to go get a picture with Darragh. Go just tackle him and say, "Hey Darragh, picture, selfie, boom, done." And send it to us on Discord. Send it to us on Discord right here, and send it to me, Fixer, on Discord, and we'll send you a $50 Amazon gift card. There you go. Picture with Darragh.
We do the Corey Quinn thing, you know that.
Yeah, that one. All right, cool. Mark, anything from you? I'm sorry.
Come and see us at Embedded World.
Embedded World.
Coming after MWC.
After MWC, same thing goes for Mark. Go tackle Mark. Get a picture with Mark and get an Amazon gift card.
Super.
All right. There. So I'm going to close this out now. Gentlemen, thank you so much for your time. As always, you're always welcome on this show. Darragh, you've been kind of an all-star with us here on Innovation Coffee over the last year or two now at this point. Mark, thank you so much for joining us. PARSEC expert here, bringing some great information and stuff for the viewers and myself especially. So always look forward to learning from you too. Thank you so much. And for everyone out there watching, this has been another great episode of Innovation Coffee brought to you by ARM. Once again, I'm Robert Wolf, your host here, joined by Darragh Grealish and Marc Meunier. Darragh from 56K Cloud, Marc Meunier from ARM. It's been a pleasure having you both here. It's been a pleasure having everyone watching us. If you enjoyed the video, don't forget to hit that like button right below. If you missed anything during the presentations, during this episode, we will be sure to provide links to all the resources we talked about. Don't forget to subscribe to us on ARM Software Developers YouTube channel and ARM Software Dev at ARM Software Dev on Twitter for any updates surrounding this. We're here every Thursday, 5 p.m. UTC. And Darragh, what's this?
Buy one of these.
And buy an RB5.
An RB5. Let's do it.
There you go. 96boards.org. Go check that out. They have the RB5s there available. Thank you, everyone, so much. Take care. Have a wonderful rest of your week. Wonderful weekend. We'll see you next week.
Yeah.